finally we pay taxes. And this year we paid a lot of taxes. And I benefited from physics in the sense that actually I wanted to be a physics researcher when I was young. But unfortunately, I started science and mathematics quite late. I started about 13 years old. And that has a great benefit in that sense. In the sense that I learned physics and mathematics parallel to each other. And I had no preference of which is actually the queen or which is the king. When I was 22, I asked my professor, because I was given a scholarship to study nuclear physics. So I asked my professor that since all the equations in physics are mathematical equations, yet all these equations represent only a very small fraction of mathematics. The question is, what about the remaining part of mathematics? And obviously, I was not a good student, that I could not stick to the rule. And I left school, even though I was offered a place to teach in the US. I joined IBM, and I thought life in school, in universities, was over. And I agree with Professor David that science is fun. And I told my wife that the most happy part of my life is about waking up in the morning, still wanting to read something, and still being excited about new things going on in this world. And I'm still alive. Today I'm going to give a talk on category theory, which was accidentally discovered in 1941 by a student of Amy Noether. And Amy played a very significant role in physics because she was the one who proved Noether's theorem, that the foundation of general theory of relativity. In a way, my work, my whole life's work, is actually interrelated with physics, and that was why I paid taxes to physics. Now, it was a very simple idea that I raised in IBM, that why are we programming codes randomly without any theory or any system? And I couldn't accept that. I couldn't accept that you have to detect syntax error using your own manual method. And I thought physics goes around group theory. And the question that I asked when I was young, what went around group theory could be very important in solving this problem. Now I started a company writing codes based on the concept of group theory. And 10 years passed, and it became a multi-billion-dollar company. And we were way unicorn long ago, before the word unicorn was invented. And yet it was based on a simple question that when I was your age, asking the question, if physics is all about small core of mathematics, then what is the remaining part of mathematics? Now I try to answer them, and today I will give you a glimpse of what I thought goes around physics. So you can read this. Category theory is a very interesting theory that is neither pure or applied. Now this is very important. We tend to look at things pure or applied. But nature doesn't really care. Nature doesn't care whether it's pure or applied. And the truth is, we study nature. So therefore, there is no such thing as pure or applied, and category theory actually supports that fact. Now it is, in that sense, category theory is more about imagining nature within mathematical frameworks. Now I talk about it was accidentally discovered, therefore not a continuation of our normal mental frame. Now, that I also want to highlight that if you are looking from the category theory point of view, then I think our current education system, our current economic system needs to be adjusted. Now let's start. So we're talking about, Professor David talked about Industrial Revolution. And Industrial Revolution was based on a few simple theories. And that was mechanics or Newton's law. Then electromagnetism or Maxwell's law. Then the quantum physics, which is encaged in Lie groups. And the fourth industrial revolution, which is based on Turing Church thesis, computerization. But if we were to look at the whole history of humankind, now for a long period of time, actually, we study things that are visible. We invented characters, figures, numbers, and words. And for the first time that we try to look beyond visibility or audibility, we reach a point from the time of mechanics where we start talking about gravitational force. We talk about weak force, strong forces, well, various forces. So we start to appreciate invisible things, and that revolutionizes the world. Now we can call that two periods, the period of visible things and the period of invisible things. But what about mental things? What about things that we know so well in our brain? Where they belong to? And I think that was the question that I asked when I was your age. And so why we classify the invisible, physical, mathematical equations the same period because they belong to invariant. They actually all of them satisfy group theoretical condition. That's why we call them symmetry, we call them conservations. Now they all belong to the one particular category of mathematics. But mathematics does not stop there. In fact, there are infinite categories in mathematics. So that the question that I asked when I was young was, what about 0 category? What about 2 category? What about 3 category? What about 6 category? Now there are theorems that say that we can't get out of 6. Feature theorem says that we can't get out of 6. But we cannot get out of 6, I can understand. It could be our own limitation. But category theory does not stop at 6. So, in a way, we can actually rearrange the word space-time. I purposely turn it around and call it time-space. I believe time comes first. It's not space comes first. So time-space. Now, and if we were to arrange it according to category theory, then there was a period that we look at visibility. Then we move on. Then we would go into the world of invisibility. And that was one category. Because one category is actually group theory. They are the same thing. And all the physics equations are captured inside one category theory. Now that, if we were to look at it in the time-space from that perspective, maybe there are other things that we can discover. There are other things that we can see. Now, I like to arrange all this in tubes of categories. Now, in set, if you have touched on set theory, if you have studied set theory, just imagine the set is a tube, and everything is very much like set theory. Now, it's multi-dimensional set theory. Think of it that way. And we can see a lot of tubes and they interact. And as you know, open sets can actually combine in a very interesting way that you get topology. And so all the abstractions in life are in a way not very surprising. But in everyday application, of course, just like physics, you have to apply it. Otherwise, it is all talking about stories, which is fine, because you can take my talk as a joke. And if you enjoy the joke, well, pay me the tickets. So in a way, that's fine. But so what are the applications? And that can be on testing theories, that can be so-called apps in computer world, that can be concepts in philosophy, in mathematics, and in politics, in theology, and in mathematical terms, we call them generic figures. Now this term was used by a young mathematician, Harman Zohari, in his book called Theory of Generic Figures. But in more formal term, you would call the theory of C-set. Now, if you cut these so-called tubes, if you cut these tubes, you actually get circles. So you actually get the normal set theory. And so, if these tubes are concepts, they are theories, they are generic figures, So what is that one-dimensional, two-dimensional picture of circles? We call them knowledge. Now, so the rings of knowledges, we call them chemistry, we call them physics, we can call them economy, but it lacks lives. And it lacks emotion. So we also can see that there are subtubes concepts, like subsets concepts. Now as we move on a bit, and how tubes can be formed, it's actually very easy to build a tube. Just go to Google, just ask images of books on mechanics, and you find a whole lots of them, and you just save as pictures, and you stack them all up, you get a tube. And yet, that tube is just one simple equation, F equal to dmv dt, which is shocking. How orderly is this tons of books? Just one simple equation, F equal to dmv dt. Now, the tough part about the conversation here is choice. In category theory, you are allowed choices, unlike traditional mathematics, which you are not allowed to. In modern, or so-called the frontier of mathematics, you are allowed to make choices. So, the question of what is all this for? Well, knowledge is definitely very important in life. That's why we go for education. That's why all of you are here. But there are different approaches to attack problems. And when you are used to equations, sometimes that can be very efficient, can be very effective, very accurate, and simple, far-reaching, and time invariant, which is a difficult word. You need time invariant for everyone to work together. If we talk to our ancestors 3,000 years ago, they won't understand what we are talking about. Time invariant, it is very important in organization theory, because we need to talk and we need to communicate. Now, the good thing about so many books is that we have details, but we also have over-information. And this is what you're going to face. In your generation, your biggest problem is about over-information. And it's going to weigh you down if you don't solve that problem of over-information. It is going to be very heavy on you if you do not ask this question: how am I going to escape from this problem of over-information? Now, so I will summarize that we try to introduce the concept of category theory, time-space. And all time-space should be built on certain endpoints, not like purposes, not truth. I believe we are millenniums, maybe zillions of years away from truth. Category theory time-space is economically powerful. We build category time-space by focusing on invariant and symmetry. Traditional time-space is based on historical habits. Plato said that it was about truth. And around the same time as Plato, Aristotle actually coined this word called category theory. Category. It disappeared around 1850 when most people thought it's not something you can continue. And in category theory, things tend to be inverse from what you know. So I purposely turned the word space-time into time-space. Now, whether it is space-time or time-space, we know that space-time or time-space is curved, whether from experience or whether from physics. Now, which means there's something called minima, which means there's something that can be of minimal effort. And if you look at it from simple mechanics, this potential energy of climbing mountain that you have to well, I can't point it. You can see the valley, and of course you can climb the cliff, which is tough. And that means economically not viable. Now compare that to what you are learning today. I commented that we are going to face a big problem on over-information. And yet all our universities are still teaching knowledge. And as Louis Wittgenstein said, knowledge is to be acknowledged, and acknowledgement needs knowledge, and knowledge is going to be acknowledged again, and you are going to go in a circle and circle, and that produces something called Cobb-Douglas effect, which is Cobb-Douglas function. It basically is a function that you see here. It goes down very quickly. And why physics is based on group theory is partially because that's the most efficient way to attack the problem of nature. And everything will go around the most efficient way. And that I will say physics is here to stay, because we will still need to go around that one category theory, even though we may go out to explore further theories. So I'm going to remind you that knowledge is limited. And we know that what we know is just a fraction. It's just a little fraction of nature. Just ask where life comes from and where lives go. That's it. It's enough to torture every scholar. And Louis Wittgenstein said knowledge is to be acknowledged. Then how you acknowledge knowledge? You use knowledge. It's a paradox. Now, how are we going to resolve that problem? It is what category theory looks for. Because if we are not going to solve this problem of limitation and paradox, we are going to spend our whole life chasing our own tail. And that was why I dropped out of research, because I just couldn't answer to myself why I'm chasing my own tail. Now, the worst deal, we always thought logic is complete. That A implies B, B implies C, and A implies C. Now, that was what we thought. We were taught in school, and we proved in mathematics, A implies B, B implies C, therefore, quite easily proved. But what if I say A knows B, A likes B, and B likes C, but A has no opinion of C? Is that illogical? No, it happens every day. It is real life. It happens every day. So, is that something that not solvable? No, it can be solved. We call that category theory. Now, that logic, we call that 2 point. Now, if you are insisting on traditional logic, A implies B, B implies C, and A implies C, then you are going to find in your life, you are going to struggle with more than 170 so-called cognitive biases. And that's why I said our education teaches us about 90% wrongs. And if our education can teach us 10% right, and most of us will say no, that cannot be. If you are 10% right in your life, you are actually a multi-billionaire. Because just invest 11 times, you make your money, your gains is exponential. Just imagine if you were 10% right in economy, is actually a huge success. But then you said, that doesn't make sense, because in school, my teachers and professors give me right and wrong. Well, that is called education system. The truth in day-to-day life is that all the ideas are done so many times, so economically inefficient, just to make it right. To design an engine, it would need you to test so many times before it actually becomes an engine. And that is true in software. And that was the reason why I gave up and I asked IBM. I said, it makes no sense why we should test it so many times. It makes no sense. And I came out with a few methods. IBM supported me for a while, and they thought it is not something interesting, and I left to do it myself. So we discussed the problems of knowledge, highlights the problem of education today, and also the advantages of treating our current situation as a new time space. Don't be afraid of challenging the existing views. Create your own time space. After all, it is your life. Move on. Now, I'll just give a very brief introduction. This part, please don't pay too much attention. This is the tougher part. It's just to give you a glimpse of how category theory was built. Okay, move on. This is the tough part, where the philosophy has to come in. For example, the introduction of sigma, which basically effectively say sigma dot 1f equal to sigma, means nature look at you, whichever way you look at it, yours look at it. No matter 1f is the way you look at things. Now, sigma is nature. Nature transforms whatever you look at, whatever things, they are still part of nature. No matter how you look at it, they are still nature. And then from that, your views becoming something that we can mathematically base. And that is A, B, and a functor F. Now, if you were to play with this enough times, in a mathematical framework, you get something called limit. Can we? No. Go back. You are going too fast. Move on. You try to skip all the equations. Okay, no, stop. Come next. Okay. Now, this is limit. This is limit, and actually, everything in category theory is a limit. Okay, move on. Now, and one thing to learn in mathematics is that we only play with, most of the time, everything, 2 at a time. That leads to the question of why not 3? Can we actually operate 3 at a time? I'm still thinking, I don't know. But 2 at a time is actually very, it's the normal way that we play in mathematics, 2 at a time. Now move on. Now, that if you symbolize them, what you get is all these things which every one of them you really have to think very hard. You have to think very hard, and that will lead you to ask why I study mathematics, because it's so boring, and in everything you need to think very hard. And I told my kids, for every mathematical equations, please don't try to understand it in 2 hours. I said, remember, this equation is the life of a great mathematician. And so don't try to be greater than great mathematician. Don't try to understand mathematical equations in 2 hours. Try to remember it. Keep thinking about it. It may take you whole life. Okay? And well, the importance of studying these symbols is that if you are a software engineer, you need to understand the differences between these equations. Now, as Mercedes CEO said, my competitors are no more Nissan, Toyota. My competitors are Tesla, Google, Apple. Now, so in your generation, you are going to have your competitors as Tesla, Google, Apple. And it's going to be a different type of competitors. And you may need to worry about all the symbols. We move on. Now, if you were to play with these symbols a bit more, then you have category theory, you have shift theory. And it leads to a question of choice and a question of determinism. What is deterministic and what is choice? Now, choice is the way you cut across the tube. You cut across the tube, you get different type of knowledges, but the tube is natural. It's deterministic. Okay. Move on. Now this, if you were to expand it further, you will reach a point that is called theory of generic figures, or you will call it CSAT. And I apply it to economic theories. And in this case, very much is a work copied from other mathematicians. So it's not my own invention. And it's just a nice way of representing it. And this is the picture that I drew. But all our works, like what Newton said, we actually always sit on others' shoulders and work from that. Now, so if you were to ask me what I see in these equations, I see exactly what every physicist sees. Well, we see nature. Now, you cut a line across all these pictures, what you get? Fourier transformation. Okay, we come back to circles and circles and circles of things. Okay, and imagine Fourier transformation stack up, you get a tube and tubes and tubes of things. Move on. Now, these are some books. You can get a copy of my presentation. If you're interested, you can read yourself. It's definitely not something that you really specialize in your undergraduate work, but it's very good to start reading when you are undergrad. Move on. So summarization here, well, that category theory being accidentally discovered is not a usual continuation of your thought. Well, most mathematicians were at a loss. In fact, they called it theory of nonsense for many years, until it was more or less unified in 1960s. Now, category theory is neither pure or applied. And I think we're caged in this concept of pure or applied. Why should we? Why should there be something pure? Why should there be something applied? It's nature. Nature always is the same. Sigma is always sigma. No matter sigma dot 1f is always sigma. Nature, no matter how you look at it, is still nature. Now I take it as a theory of visualizing everything, inclusive of mathematics. But it makes use of frameworks of mathematics. So it is not really mathematics, but making use of the framework of mathematics, make it mathematics. And that was what I struggled with, even with mathematicians. Somehow, they won't take me as a mathematician, neither anyone would take me as a physicist. I think it is a theory of our mind. And so, category theory is much like the equation that you saw in physics. So in a way, the easiest way to understand category theory is actually play around with it in your everyday life. And that was what I enjoyed. The last 60-something years, I started dreaming when I was around 7 years old, and I think I really enjoyed dreaming my whole life. Now, sometimes new things you have to apply to economy, because economy is about less wrongs. If you are in science, people expect you to be more rights. When you come out with theory in physics, and if 8 of the times it is true, and 2 times false, they say that your theory is incomplete or not very right. But in economy, if you are 10% right, you are multi-billionaires. Because you just did it, you just do it 20 times, you are going to be multi-billionaires. Now, so in a way, sometimes science is better to attack it from an economic point of view, because economy is about less wrongs. And as a starting part of science, we have to accept less rights. And therefore, it's the concept of less wrong. Move on. Now, so I started this company based on a simple concept that we should build computer models based on group theory. And it was an easy life. It went very smooth, and it crossed multi-billion. Cannot? Okay, now, from there, let me say it without charts, and hope you can capture. I hope you can start imagining category theories. There are types of things. There are types of things, and obviously, if you are going to attack the problem, you attack the simplest problem first. And the simplest problem is exactly what the simplest approach was exactly what the physicists did. They took the group theoretical path. Can you move on? Move up. They took the group theoretical path. And that was exactly what I did in software. I took the group theoretical path. And that makes me a billionaire. And that is the why I come here to talk. One of the reasons is I find that when I was young, actually I wanted to be a physicist. But at the same time, I was struggling with myself because I came from a very poor family. So I actually wanted to make sure I can feed my family. And I struggle with myself. Now, I know a lot of you, maybe in your life, you are going to face a challenge of whether it's about economy or whether it's about science. Now, I come here to talk, actually, is to tell you, even if you have to take an economical path, commit your life to science. I think one reason is what I still tell my wife, that when I wake up, I feel so happy because I still want to know. And I'm still living as though I was 18 years old. And that I thought is more than all the money I have. Because what can you do with your money? But if every day you can wake up and be happy with yourself, I think that is the biggest success. Move on. And let me have a quick introduction of what is move on. Move up. Can you move up, please? Up again. I just want to introduce up, 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 up. Now, this is over information. Just Google, okay, computer acronyms, Google financial acronyms, and you go through them, and you find that if, just ask yourself how much you know about the terms, and I can guarantee you, you know less than 10%. So you are going to face this world. You are 18 to 25, maybe. I think you are going to face this world that you are going to go into society knowing so little about the challenges of society. Yet you are going to face them. Now, so the solution is find a way to live in this world of over-information. Now move on, move up. And I will show you my last few charts. Move up, move up, up, up. Maybe I will do it because the last few charts is okay. So you have heard of fintech, you have heard of blockchains, you have heard of Internet of Everything, you have heard of artificial intelligence. Now, what are they? And if you arrange all these challenges along the categorical line, artificial intelligence or augmented intelligence is in the range of 0 to 1. And shift theory is about the way, the connection between the 0 and 1 category theory, and which sometimes you call it logic, but in a multi-dimensional logic, we call it 2 point. And group theory is where the whole knowledge go around. And physics is 100% group theory, and everything go around that group theory. And that our company, Silverlake, was built based on group theory, so that was a core of Silverlake. And 2 category theory is a very interesting world. It is actually just like 2 black holes going around each other. And that is very important. You find that in physics, one piece doesn't work. You tend to have at least 2 pieces. And fintech is actually, if you trigger mathematical theory, there is one important theory called Fisher theorem, which says that every combination of these symbols actually leads to sixes. Now, it is a very tricky problem that took nearly 300 pages to prove. And therefore, you can't attack this problem whole, so you attack it as lines. When you attack it as lines, we call it fintechs. So Facebook is fintechs, Google is fintechs. So all this, when you attack a problem like search, and that is actually, you are trying to reduce the problem into a line. So that is how today, how we organize our company. So today we have 6 groups of company. The first one listed in Singapore and is a multi-billion-dollar company. And the second group that is going to be listed in Hong Kong, which is FinTech Group, and some other companies listed in China and in New Zealand. But by and large, the Silverlake axis deal with group theory, and FinTech deals with 2 to 6 category theory. And then we have cloud computing and government and governance, and IoT and ITMT. And of course, if you know all this, you actually can easily invest in good companies and make a lot of money. So in a way, it's a very interesting thing that go around physics and mathematics, and yet intertwined with economy. Now I would like to conclude and find some charts. Maybe I will conclude with game theory. Now if you read Nash, now if you read Nash game, now you'll be wondering. Now Nash famous quotation was all games end in symmetry. Now what's symmetry? Symmetry, again, is group theory. So we are going round and round group theory. But what is outside group theory is something that I have explored for the last 63 minus 7 years. Now that's 56 years. And I would conclude that it's category theory. Now it is a new subject. It is not easy. You can't even get a professor that is very fluent in this theory in Asia. There was one in New Zealand by the name of Professor Robert Goh. Unfortunately, mathematical professors are less sociable. I invited him to come here and talk. He said, no. And so, but I think you are in a world of over-information. You have to have a strategy to deal with this. Professor David asked you to ask a question. You have to ask a question and answer it yourself. The best is that question lasts your life, and you will find your life very interesting. Thank you very much.